This video is going to cover the topic of factors, multiples, and the cake method. Be sure the date and topic are at the top of your page. The essential question for this video, which also should be on your page, says, what are factors and multiples, and how do we use the cake method? Sometimes with fractions and other scenarios, we'll need to know how to find factors or multiples of numbers. So let's be sure we all agree on a definition of factors and multiples. I want you to first take a moment to think about the word factor and kind of reflect on what you think it means from your previous experience. Here's what I thought of. I thought of factors as values or a value that can be paired and multiplied to make a larger number. So for example, the number 10 has factors, and 1, 2, 5, and 10 are all factors of 10 because 1 times 10 makes 10, and 2 times 5 makes 10, right? So that makes them factors. And while most numbers have factors, right, some numbers don't have very many. Some only have a factor of 1 and itself, and we call these numbers prime. You might have a list of prime numbers in your spiral if you take a look, right, if you got it from school. Examples of prime numbers might be 5, 7, 11, 13, right? There's a whole bunch of them, right? Numbers that you can't find more factors than just 1 in itself. And similarly, we want to think about the word multiples. So take a moment and think about what you know about the word multiple already. And I wrote down that a multiple is the product you get when you are multiplying a number with another value. So again, for example, the number 10, the multiples of 10 are infinite, right? They will never stop, but we could do 10 times 1, 10 times 2, 10 times 3, 10 times 4, and so on. Those will go on forever, right, if we take 10 and multiply it with another value. And as you'll see as we go forward, sometimes we need to find common multiples or factors for a pair of numbers. There's lots of reasons for that. We will talk about those together. But right now I want to show you a strategy. If you're anything like me, in elementary school, when you were looking for the least common multiple, you often made a list, right? So if I want to find the least common multiple of 4 and 6, I might make a list like this and then look at the list and say, oh, 12 is on both of their lists. It's the first one I see. Their least common multiple is 12, right? Or if I'm finding the greatest common factor, I might list out all the factors of 4 and all the factors of 6 and say, oh, the one that they have in common, that's their biggest, right? They have 1 in common, but bigger than that is the number 2. Their greatest common factor is 2, right? But that's kind of cumbersome, and you're often going to miss numbers. I see it all the time with students that you forget a factor, or when you're counting by 4s, you miscount. So I want to show you a different way, and I call it the cake method. Some students call it the upside down cake method. Some people call it a chandelier method, whatever works for you. But I'm just going to use the quick name cake method. And I'll do the cake method here to find the least common multiple and greatest common factor of 12 and 14. So I'm going to go ahead and put 12 and 14 kind of near, 12 and 44, 12 and 44. And I'm going to kind of put it in a little half box, right? A little L shape. And I'm going to think to myself, what can I divide 12 and 44 by? And I can think of anything. I often try to look for prime numbers because they're kind of friendly. So I'm going to say, oh, they can both be divided by 2. And when I do that, 12 divided by 2 is 6. 44 divided by 2 is 22. So I've divided them both by 2, and now this is what's left. But I know 6 and 22 can also be divided by 2, so I'm going to keep going. And I'm going to say, oh, well, 6 divided by 2 is 3, and 2 can go into 22 11 times. And now I'm going to look and think about 3 and 11. I don't think they can be divided any further, right? If I divide by 1, it doesn't really do anything here. So this is where we're going to end. Now, to look for the greatest common factor, I'm going to look at what I have already divided by. I divided by 2 and 2. My greatest common factor is what I get when I do 2 times 2. Their greatest common factor is 4, right? Then if I want to find the least common multiple, I'm actually going to take my 2 and my 2 and the the last row of my little cake. You can see it's kind of like an upside down tiered cake. And I'm going to say, oh, so my least common multiple is what I get when I do 2 times 2 times 3 times 11. And I'm just going to do a little calculation in my head here. And I end up with 132. That's their least common multiple. And that's a lot faster than if I had tried to count by 12s and by 44s and looked to see where they met up for their least common multiple. Lots of room for error if I do that. But this is a little bit faster. I'm going to go ahead and try it again, finding the LCM and GCF of 32 and 24. And again, these are kind of annoying numbers. I don't want to have to count by 32s and 24s to find their least common multiple. So I'm going to look at this and see what I can do. I'm going to make an upside down cake, right? My tiers are going to get smaller and smaller as I go down. Well, I know 32 and 24 could both be divided by 4. So I'm going to do that first. And I'll think, well, 32 divided by 4, well, that's 8. And 4 goes into 24 6 times. But I think I can go further, right? 8 and 6 can still both be divided by 2. And 8 divided by 2 is 4. 6 divided by 2 is 3. Right? And I know I've kind of hit the end of the line there. 3 is a prime number, so it can't go any further, and 4 can't be divided by 3 either, so that's as far as we're going to go. And I'm going to look for my greatest common factor. I'm going to switch colors here. My greatest common factor is what I see on the outside. It's the ones that I have divided by, and I'm going to just combine them. So 4 times 2 means their greatest common factor is 8. One thing I think about when I'm doing the least common multiple is this kind of makes a shape of an L all the way around here. So that means I need to do 4 times 2 times 4 times 3. And of course, that would tell me that their least common multiple is a whopping 96, right? And that would have probably taken me a bit to get there had I done it with a different strategy. And I'm going to leave you with one more for you to try on your own. So I'd like you to find the least common multiple and greatest common factor of 8 and 20. And I've set it up the way that I would do it. And you'll go ahead and fill this in, and then you're going to try on your own. And I'm going to be looking, when I look for your notes, for your answer to sort of check and see if you're on the right track. So be sure that that is visible for me when I look for your notes. And remember that the essential question of this video was that we wanted to find out what factors and multiples are and what the cake method is. So hopefully you had a chance to see that. Be sure to watch the video again if you need to, and come in with questions when we meet together again next.